In this question, it's asking us to practice balancing chemical equations. So we have three different examples. In the first one, what we can see is that it's a word problem. So that means that we need to A, remember our elements and our polyatomics, and B, be able to read the states out of here. So for solid barium carbonate, when heated, decomposes into gaseous carbon dioxide and solid barium oxide. So it's a lot of different parts. So we know that barium is Ba, and based on its place on the periodic table, is 2 plus. Carbonate ion is CO3, 2 minus. So together we need one of each. So we have barium carbonate, and we know that it's solid, and it's going to be heated. So that little delta sign means heated, and it's going to decompose into carbon dioxide, which means one carbon, two oxygens. So we have CO2. So CO2 gas. And it's going to also be solid barium oxide. So Ba for barium 2 plus, and oxide is 2 minus. So that also is a 1-to-1 ratio. So plus barium oxide, solid. So in this case, when we check, this equation is already balanced. So it's a 1-to-1 ratio. So let's look at the next one. We have iron 3 hydroxide plus sulfuric acid gives us iron 3 sulfate plus water. This is unbalanced. So the question is, how do we start? So I like to look for a complex ion. And so in that case, this is the iron sulfate. And the first thing I'm going to do is start by just adding those coefficients on the other side. So I'm going to put a 2 here, and then I'm going to put a 3 here. And see, so now we know that the iron sulfate is going to be balanced. That compound is fine. So we need to confirm all of our options. So we have FeOH, and then we have H and SO4. So in the before and the after, so we now have 2, 6, 6, 3, and we have 2, 1, 1, and 3. So if you're thinking, how come you left the OH together and the H's together? Well, in this case, this is a neutralization reaction. And so what we know is the base unit, the OH, and the H come together to make water. So in this case, this was an acid, sulfuric acid, a base type compound, iron hydroxide, and together those made salt, iron sulfate, and water. And so in this case, in order to balance this, we're going to put this here. On the exam, you would be asked to rewrite it to 2FeOH3 solid plus 3H2SO4 aqueous. Yipes, I'm running out of space here. Gives you Fe2SO4 3 aqueous plus 6H2O. So there's our balanced chemical equation. It's kind of going everywhere. So I'm going to move this slide up so we can have a little bit better space. So in our next equation, it doesn't give us the states. I'm not asking you to find the states. You just need to know that if there are states, you should write them. Or if I give it to you in a word problem, you should write them down. So here we have aluminum nitrate plus sodium sulfide gives you aluminum sulfide plus sodium nitrate. So I'm going to leave these some grouped together. So we have aluminum, then we have nitrate, sodium, and sulfide. And we have the reactants and the products. So we have 1 aluminum, 3 nitrates, 2 sodiums, 1 sulfur. And on this side, we have 2, 3, 1, 1. So I'm going to start by balancing the products on the reactant side. So I'm going to do that by adding a 2 here, which is going to give me a 2 and a 6. And we know that we need to have 3 sulfur on the right side, so I'm going to add a 3 here. And that's going to give me 6 and 3. So now both the aluminum and the sulfur are balanced, and we could add a 6 here, and that would give you a fully balanced equation. So we're going to go ahead and rewrite that to aluminum nitrate plus 3 sodium sulfide gives you aluminum sulfide plus 6 sodium nitrate. And so in this case, for some of these, you can kind of think like, okay, we know that the sodium nitrate is probably aqueous, and we could try to figure that out. And we forgot a 2 here. And so we can go from there. But you're just being asked to rewrite the balanced equation.